SpaceX just lost a Raptor engine in what might be the most violent test failure we've seen in months. And this wasn't some minor malfunction during a routine firing. This was a catastrophic explosion that sent debris across the entire test stand at SpaceX's McGregor facility in Texas. The engine literally tore itself apart in a fraction of a second, creating a fireball visible from several kilometers away. Now, engine failures happen in rocket development. That's not the story here. The story is what this engine was being tested for, and why its destruction might actually delay the entire Artemis program yet again. According to sources familiar with the test campaign, this wasn't just any Raptor. This was a Raptor 3 variant specifically configured for lunar landing operations. That means it had been modified to handle the extreme throttle control required for touching down on the moon, where you need to reduce thrust from maximum power down to just a few percent in a matter of seconds. SpaceX has been running these modified engines through increasingly aggressive test profiles, trying to prove they can survive the thermal stress and mechanical loads of a powered lunar descent. This particular engine was on its 14th firing when it failed. The explosion happened approximately 47 seconds into what was supposed to be a 90-second burn. Telemetry data shows the engine was throttling down from 85% power to 40% when pressure readings inside the combustion chamber suddenly spiked to nearly twice normal levels. Within 200 milliseconds, the engine disintegrated. High-speed cameras captured the moment the turbopump housing ruptured, sending fragments of titanium alloy through the test cell like shrapnel. Several pieces punched completely through the concrete blast walls, which are designed to contain exactly this kind of failure. One fragment was found nearly 400 meters away from the test stand. Now, SpaceX's official statement called this a rapid, unscheduled disassembly during a planned test campaign, which is their standard euphemism for things blowing up. But internal documents obtained by several aerospace journalists tell a different story. The failure was caused by something called combustion instability, which is basically when the burning process inside the engine becomes chaotic and uncontrolled. Instead of smooth, steady combustion, you get pressure waves bouncing around inside the chamber, creating oscillations that grow stronger and stronger until something breaks. This is one of the most difficult problems in rocket engine development, and it's particularly nasty in engines that need to throttle across a wide range of power settings. What makes this failure especially concerning is that combustion instability tends to show up unpredictably. You can run the same engine through the same test profile 10 times with no issues, and then on the 11th run, it destroys itself. That makes it incredibly difficult to prove the problem is actually solved. You can't just fix the engine and run one successful test and declare victory. You need dozens, maybe hundreds of successful firings across all possible operating conditions before you can be confident the instability won't come back. And that takes time, a lot of time. This matters for Artemis because SpaceX is already on an impossibly tight schedule to get Starship HLS ready for the Artemis 3 moon landing. NASA's current timeline has that mission launching in mid-2027, which is now just 16 months away. For SpaceX to meet that deadline, they need to complete all engine qualification testing by the end of 2026, giving them less than 11 months to not only fix this combustion instability problem, but prove it's actually fixed. Industry experts are calling that timeline completely unrealistic, especially given that this is the third Raptor 3 engine to fail during lunar landing qualification tests in the past 5 months. But here's where things get interesting. While SpaceX is dealing with exploding engines, NASA just announced something that nobody saw coming. Artemis 2, the crewed mission that will fly around the moon but not land on it, is being repositioned as a record-breaking achievement in its own right. Instead of just being a test flight for Artemis 3, NASA is now promoting Artemis 2 as the mission that will take humans farther from Earth than any humans have ever traveled. And the numbers actually back that up. The current record for the farthest distance a human has traveled from Earth was set during Apollo 13 in April 1970. When that mission's oxygen tank exploded, forcing the crew to abort their lunar landing, they used the moon's gravity to slingshot around the far side and head back to Earth. At their most distant point, the Apollo 13 crew was approximately 400,171 kilometers from Earth. That's measured from the center of the Earth to the spacecraft. For 55 years, that record has stood untouched.
Artemis 2 is going to break it. The current flight plan has the Orion spacecraft entering what's called a free return trajectory around the Moon, similar to what Apollo 13 used. But because Orion is heavier than the Apollo command module and has different orbital mechanics, the trajectory takes it slightly farther out. At the farthest point of the mission, approximately 8 days after launch, the 4 Artemis II astronauts will be roughly 432,000 kilometers from Earth. That's nearly 32,000 kilometers farther than Apollo 13 ever went. NASA is making a big deal out of this, and for good reason. It's a genuine achievement, and it gives Artemis II a concrete accomplishment beyond just being a test flight. But there's also a cynical reading of this announcement. By emphasizing the record-breaking nature of Artemis II, NASA is subtly shifting public attention away from the delays and problems plaguing Artemis III. It's a way of saying, look, we're still doing historic things, even if we're not landing on the Moon yet. The Artemis II crew, Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen are currently deep into training for a mission that's scheduled to launch in April 2026. That's just 3 months away. They've been practicing emergency procedures, running simulations of the Orion spacecraft systems, and conducting underwater training in NASA's Neutral Buoyancy Laboratory to prepare for the possibility of a water landing if something goes wrong. All 4 astronauts are experienced, with multiple spaceflights between them, though none have ventured beyond low Earth orbit before. The spacecraft they'll be flying, the Orion capsule, has been through extensive modifications since the Artemis I uncrewed test flight in November 2022. Engineers discovered several issues during that mission, including problems with the heat shield that caused more material to erode away than expected during re-entry. NASA spent over a year analyzing that data and implementing design changes to ensure the heat shield can survive the intense temperatures generated when returning from lunar distances at roughly 11 kilometers per second. The modified heat shield has been tested in arc-jet facilities that simulate re-entry heating, and NASA says they're confident it will perform as designed. But this will be the first time it's tested with actual humans aboard. One of the most significant differences between Artemis II and the Apollo missions is the duration. Apollo flights to the Moon typically lasted 8 to 12 days total. Artemis II is planned for approximately 10 days, but the Orion spacecraft is designed to support crews for up to 21 days if necessary. That extended capability is critical because if something goes wrong and the crew can't come home immediately, they need to survive long enough for ground controllers to develop a solution. The spacecraft carries enough food, water, oxygen, and power to keep 4 people alive for 3 weeks, with some margin for emergencies. The mission profile itself is fascinating. After launching from Kennedy Space Center on NASA's Space Launch System rocket, the most powerful operational rocket in the world, Orion will separate from the upper stage and spend about a day in Earth orbit running systems checks. Then, the upper stage reignites for the trans-lunar injection burn, sending the spacecraft toward the Moon at escape velocity. Over the next 4 days, Orion coasts outbound, gradually climbing away from Earth's gravity well. The crew will conduct daily health checks, test the spacecraft systems, and perform several course correction burns to fine-tune their trajectory. As they approach the Moon, Orion will pass within approximately 10,000 kilometers of the lunar surface, close enough for the crew to see individual craters and features with their own eyes. Then, the Moon's gravity will bend their trajectory, sending them looping around the far side and back toward Earth. This is the point where they'll set the distance record, swinging out to that maximum range of 432,000 kilometers before gravity pulls them back. The return journey takes another 4 days, with the spacecraft gradually accelerating as Earth's gravity takes hold. Re-entry is the most dangerous part of the entire mission. Orion will hit the top of Earth's atmosphere at roughly 40,000 kilometers per hour, generating temperatures on the heat shield exceeding 2,700 degrees Celsius. That's hot enough to melt most metals. The spacecraft will decelerate from that insane speed down to zero in about 20 minutes, pulling G-forces that will pin the crew to their seats. If everything works correctly, Orion splashes down in the Pacific Ocean off the coast of California, where Navy recovery ships will be waiting to pull the capsule and crew out of the water. So here's the situation as we head into 2026. Artemis 2 is 3 months from launch and appears to be on track to set a genuine human spaceflight record. Meanwhile, Artemis 3 is facing serious technical challenges with SpaceX's Raptor engines that could push the moon landing back to 2028 or beyond. NASA is caught between celebrating a real achievement and managing expectations for a program that continues to slip further behind schedule. And SpaceX is burning through test hardware trying to prove their technology is safe enough to land humans on another world. We're probably going to see NASA push hard to make Artemis 2 happen on time, using it as proof that the program is making progress. We might also see them quietly extend the Artemis 3 timeline, perhaps announcing a formal delay to late 2027 or 2028 once Artemis 2 successfully flies. And if SpaceX can't solve the combustion instability problem quickly, we could be looking at a much more fundamental rethinking of how NASA plans to land on the moon. Unfortunately, though, there will probably still be a lot of exploding rocket engines along the way,